Okie dokie. So we just looked at how to rearrange exponential equations to logarithmic equations because it's useful. A little later, we're going to reverse to the exponential and vice versa. That would be related to how to get the inverses because these are inverses of each other. And before we go there, if you had the log of -2, that's impossible. You can't get a negative value by applying an exponent, right? Because this would mean -2 you can get by applying an exponent to 10. Again, notice there's no 10 by the g, so this is base 10. That's not possible. You can't get a negative number by applying an exponent. So the domain of the logarithm cannot involve negative numbers. Well, what about 0? What exponent would produce 0? Well, if that was possible, same thing. Then we could do that. But you can't get 0 by applying an exponent. All right, so logarithms are only applicable greater than 0. So the domain of all logarithms is greater than 0. And that's about the simplest way to put it. But that's going to help us when we make the graphs, understanding that relationship. Okay? So just like before, we had bases between 0 and 1, and we had bases that were greater than 1. Well, the same thing with logarithms. If we're doing a log graph and the base is greater than 1, all right? Well, right here, when the exponent is 0, remember the output of the logarithm is the exponent. So when the y is 0, when the exponent is 0, that means to the 0 power, which is 1. Whereas for the exponential, that was the y-intercept. For the logarithmic, that's the x-intercept. Okay? And so, again, remember the logarithmics are the exponential. So then if we go up here, that would be an exponent of 1. That would be an exponent of 2. And that would be an exponent of 3. If we go down here, that would be an exponent of -1, an exponent of -2, and an exponent of -3. So it all depends upon the base we're using. That's how this is going to stretch out. But if the base is greater than 1, when we do negative exponents, those are reciprocals. So 1/2 or 1/5, right? And so gradually, so when we have a very large negative exponent, that means 1 over the base to whatever. So say this is 100, right? So that's going to gradually get closer to 0. And again, remember the domain. Another way to think about it. All right, notice that's a vertical asymptote. So the vertical asymptote is going to be x equals 0. Now again, if the base is greater than 1, well, as soon as we start applying exponents, then we're going to get the base to the first power, the base to the second power, the base to the third power. And so whatever that base is, when we do the first power, that's the x we get there. And then this will be bigger, and this will gradually go this way. So if you have a base that's bigger, this will gradually be over here. So let's say this was 2. Well, then a base 3 would stretch this over here. It'd take a little while longer because then that would be based on 3 to the first power, and then 3 to the second power, and then 3 to the third power. Okay, well, let's look at the graph when the base is less than 1. And then by implication greater than 0. We don't use negative bases because they're too problematic. Because if the exponent can be any real number, negative bases mean we're going to have roots of negatives, which is problematic. Okay, well now this is the reverse. Okay, when we have negative exponents, if the base is less than 1, then we're going to get bigger values because 1 over 2 flips over the 2 over 1. Whereas if we have positive exponents, then we're going to get smaller values because we're going to have a fraction with an exponent. So 1/2 to the second power, 1/2 to the third power. So this graph is going to look like this. Right? And so that's the nature of these two graphs. And then it's just a matter of moving that around based upon the transformations. So we'll look at three of those, and then we'll see how much time we have left. We're looking good for time. Okay, so let's say we had this one. Okay, and then notice here by implication, the base equals 10, so it's greater than 1. So it's going to be the general logarithmic function. All right, well, this is changing the sign of the output, the y. So that's going to reflect across the x. So starting right here, if we reflect across the x, that makes the graph do this. Okay, well, let's say we had this one. Okay, well, that's changing the sign of the x's. So now remember, we can't have logs of negatives. So the only way this is going to be plausible is if we minus negatives. And one way of thinking about it. All right, so the original graph, again, the base is still greater than 1 because this assumes base 10. All right, so now we're going to reflect that across the y-axis because we're changing the sign of the x. So now this point comes over here to -1, and now we have that. Okay, so notice as we go to the left, we get bigger negatives, and we're going to get the opposite of those negatives. So we're going to have larger y values as we go to the left. Notice in both these cases, the vertical asymptote hasn't changed because we haven't gone left or right yet. So in both these cases, the vertical asymptote was still x equals 0. Okay, so now let's look at when we have combined transformation. All right, so let's say we had 3 minus the log, and this time I'll just say base 2, and then 1 minus x. Okay, so we're going to have to analyze this a little bit more because we got a couple different transformations. Okay, well, the first thing, I'm going to just change this so that we can interpret a little bit better. So notice we're actually having a sign change before we do the horizontal transformation. We want to save the horizontal transformation for last. Okay, and then we're also changing the sign here. So we're going to have reflection across the x, reflection across the y, a vertical translation up 3, a horizontal translation right 1. All right, so our parent, that's the parent. And I'll do the reflections at the same time. All right, so that's the reflection across the x, reflection across the y. And then we'll have the vertical translation plus 3, horizontal translation plus 1. Okay, so let's go ahead and apply that. All right, so first the reflections. So that's this. All right, so we got our original graph. The base was 2, So it's going to have a base greater than 1. So it's going to go like that again. Okay, then we reflect across the x and reflect across the y. So first we'll have this, and then we'll come over here and reflect across the y. So this is where we're at now. Now we're going to move this up and down. Okay, and when we move that up and down, we're going to be basing it on not only the vertical asymptote, but also this location over here, -1, 0. Okay, so that's going to go up 3 to the right 1. And if we go to the right 1, then our vertical asymptote is now going to occur at 1. Yeah, I don't want to erase that graph. So let me go over here and just redo with the end result. Okay, so we're going to go up 3. So now this is going to have a y3. And if we go right 1, that's going to have an x0. If we go to the right 1, then our vertical asymptote at 0 is now going to be at 1. And now it's the shape of the graph doesn't change, it just moved over. So now our graph would be like this. And the vertical asymptote is now x equal 1. Okay?